Hello, welcome to Anybody Can Learn. Today we will start preparing for quiz 1. Let's solve some questions. Consider a center data set D in R4 such that every data point x1, x2, x3 and x4 in a D satisfies the equation x1 minus 2x2 plus x3 plus 3x4 is equal to 0. Standard PCA is performed on the data set. Which of the following could be the fourth principal component? So, the options given are these. So, the question asks to calculate our fourth principal component. The dimension of our dataset D is 4 because each point in the dataset has 4 coordinates and the coordinates are x1, x2, x3 and x4 are the coordinates of each point. Therefore, our dimension is 4. Before applying the equation, we can choose any point in a 4D space. But after applying the equations, we will choose only those points which satisfy our equation. So that means not every point is allowed, everything gets changed. The points which depends on another are called as independent variables. Now let us solve the equation for x4. So 3x4 is equal to minus x1 plus 2x2 minus x3. Now divide both the side by the 3. So x4 is equal to minus x1 plus 2x2 minus x3 divided by 3. So now the x4 is not free. It depends on x1, x2 and x3. So after applying the equation, x1, x2 and x3 are free, but x4 is force. That means it depends on x1, x2 and x3. So what do you mean by the degree of freedom? A degree of freedom is the number of values you are free to choose independently. In our question, after equation, we can choose only x1, x2 and x3. Therefore, 3 variables remain independent. The formula for remaining dimension is variables minus independent equations, that is 4 minus 1 is equal to 3. So what is a hyperplane? In 2D, equation x plus y is equal to 5 will form a line. A line is a one dimension. In 3D, equation x plus y plus z is equal to 5 form a plane. A plane is two dimensional. In 4D, equation x1 minus 2x2 plus x3 plus 3x4 is equal to 0 forms a three-dimensional object. Since we cannot draw a 3D object inside a 4D, mathematicians call it hyperplane. All valid data points lives on this 3D hyperplane. Now link this PCA. We know that PCA looks for a direction in which data vary. Our data is confined to a three-dimensional hyperplane. Data can vary only in three independent directions. That means data can vary only in x1 direction or x2 direction or x3 direction because they are independent variables. That means they have independent directions. PC1 will have the largest variance, PC2 have the second largest variance, PC3 has third largest variance. PC4 has no variance because its variance is 0. Moving in the fourth direction, would take the point of the hyperplane. Since the data lie on a 3D hyperplane, there are only 3 directions with a non-zero variance. That means the fourth principal component must be perpendicular to the hyperplane. Perpendicular means normal. For a hyperplane equation, a1x1 plus a2x2 plus a3x3 plus a4x4 is equal to 0, a normal vector is formed by the coefficients. a1, a2, a3 and a4 are the coefficients. Therefore, in our equation, 1x1 minus 2x2 plus 1x3 plus 3x4 is equal to 0, a normal vector is formed by its coefficient. So, a1 is 1, a2 is minus 2, a3 is 1, a4 is 3. Therefore, normal vector is 1, minus 2, 1 and 3. A principal component must always have a unit length of 1. Compute the length using the Euclidean norm form. Norm of V is equal to square root of a square plus b square plus c square plus d square. Now substitute our normal vector values. So norm of V is equal to square root of 1 square plus minus 2 square plus minus 1 square plus 3 square. So after computing, norm of V is square root of 15. Normalize the vector by dividing every component by square root of 15. So our PC4 is 1 upon square root of 15 into bracket 1 minus 2, 1 and 3. The negative vector 1 divided by square root of 15 into bracket minus 1, 2, minus 1 and 3 is also a valid PCA. PCA directions are defined up to the sign. Therefore, the correct options are A and B. Consider another question. Consider a polynomial kernel of degree 2 on a feature space of dimension 5. How many features will the transform space have? Now understand some basic concepts. What is a feature space? A feature space is simply the space formed by all the features. Consider a 2D example. Suppose every point has two features, x1 and x2. For example, point 25. Then this point lives in a two-dimensional feature space. Now extend it to the n dimensions. If every point has four features, x1, x2, x3 and x4, then the feature space is 4 dimensions, because the feature space is simply the space formed by all the features. But why do we need a feature transformation? There are some classes that cannot be separated using a straight line. A linear classifier struggles, so we transform the features. Now look at this original data. We cannot separate this data using a straight line, so we transform it. So after transformation, they become linearly separable. So this is the purpose of feature transformation. What do you mean by the polynomial feature? Higher degree polynomials create more features. If the original feature is x, then degree 1 will have only x. If degree 2 will then have x and x2. Degree 3 will have x, x2 and x3. Suppose our original feature is x, then the degree 3 transformation become 1 x, x square and x cube. What is polynomial kernel? A polynomial kernel allows an algorithm such as an SVM to behave as if it had transformed the data. Benefit of polynomial kernel is that it computes without explicitly computing every transform feature. So, k of xz is equal to x transpose z plus c raised to t, where x is a first input vector, z is a second input vector, x transpose z is a dot product between x and the z, c is constant, usually 1, and d is degree of polynomial. How do we count these features? Instead of listing every polynomial term one by one, we can compute it by formula. These include the constant terms and all the degree from 0 to d. So, the features are calculated by the formula n plus d choose d, where n is the number of original features and d is polynomial degree. Recall that n choose r is equal to n factorial divided by r factorial into bracket n minus r factorial. Now apply this formula to our problem, where original dimension, feature space of dimension 5 means our original dimension, and polynomial kernel degree is 2, that is d is 2. Now substitute these two in our formula of n plus d choose d. So 5 plus 2 means 7. So 7 choose 2. Solve it. So 7 factorial means 7 into 6 into 5 factorial divided by 2 into 7 minus 2 factorial, that is 5 factorial. So 7 into 6 divided by 2, 7 into 6 means 42 divided by 2 is equal to 21. Therefore final answer is 21 transform feature. Now solve another question. Consider a Gaussian kernel where k is a function r2 cross r2 to r with a sigma is equal to 2. Compute the value of k for the point 2, 3 and 5, 7 and enter your answer correct to the 2 decimal places. First, understand what is a kernel. A kernel is simply a function that tells us how similar are these 2 points. For example, consider 3 students. A student A has a maths score 90, science 85. Student B, maths score is 91 and science score is 84. Here these A and B are very similar. Now consider the another student C with math score 10 and science 20. C is very different from the A. The kernel output is always a single number and it ranges between the value 0 and 1. A large value, a value close to 1, that means points are very similar. A smaller value, value close to 0, point, that means points are different. But why do we need a Gaussian kernel? Many machine learning algorithms cannot separate data using a straight line. Example, support vector machine, support vector machines, kernel PCA, Gaussian processes. Straight line cannot separate this center point. So the solution is that the Gaussian kernel implicitly maps data into a higher dimensional space. In this new space, a simple linear separator may exist. Instead of explicitly computing this mapping, we do something simpler. We directly compute a similarity values between the pairs of a point. Why is it called a Gaussian kernel? It came from the Gaussian, that means normal distribution. So highest point is at a center and it decreases smoothly as we move away, and this is our distance. So the core logic is that the curve is highest at the center and it decreases smoothly on both the sides as we move away. A Gaussian kernel follow this exact the same logic. The further the 2 points, the smaller their similarity becomes. The formula to compute the Gaussian kernel is k of xy is equal to exponential of negative square Euclidean distance between x, that is x minus y, divided by 2 sigma square. Kxy gives the similarity between the 2 points, where x is the first point and y is the second point. Exponential function e to the power of something. E is a Eulerian number that is approximately 2.71828. Norm of xy is the distance between the 2 points and square it the Euclidean distance. Sigma means control how quickly the similarity decreases with the distance. The larger the sigma means similarity decreases slowly. Small sigma means similarity decreases quickly. The question gives the following values: x as a 2, 3, y as a 5, 7 and sigma as 2. Now find the difference between these 2 points, x and y. So x minus y is equal to 2, 3 minus 5, 7. So 2 minus 5 will give minus 3 and 3 minus 7 will give minus 4. Therefore x minus y is equal to minus 3 minus 4. Now find the Euclidean distance. Euclidean distance is calculated by the formula norm of x minus y is equal to square root of x1 minus y1 square plus x2 minus y2 square. So substitute the values: square root of minus 3 square plus minus 4 square. This will give norm of x minus y as 5. So the Euclidean distance is 5. Now compute its square. The Gaussian formula requires the square norm of x minus y, therefore square it. So square norm of x minus y is equal to 25. Now compute it to sigma square. Sigma is 2, therefore 2 square is 4. So 2 into sigma square is 8. Now substitute this value in our formula. So k of xy is equal to exponential of minus 25 divided by 8. Minus 25 divided by 8 is 3.125. So k of xy is equal to exponential of minus 3.125. That means exponential of x means e raised to x. E is given as 2.71828. So e raised to minus 3.125 is approximately equal to 0.0439. Round it to the 2 decimal places, therefore our final answer is 0.04. Now interpret this answer. The distance between the 2 points is 5. This is relatively larger as compared to sigma is equal to 2. Because the distance is large, the similarity becomes very small. The Gaussian kernel correctly gives it as 0.05. Because the 0.05 is very close to 0, we can say that the 2 points are not very similar. Now consider another question. Consider the following data points in a clustering problem with 5 data points and 3 clusters. 3 cluster means k is equal to 3. So these are our 5 data point A, B, C, D, E and F. Now look at their coordinates. The question is that k means plus plus is used to initialize the 3 means. The first mean is chosen to be mu1 is equal to 0 0 and second mean is to be mu2 is equal to 2 3. Find the probability of choosing phi 3 as the third mean. That is, compute probability of the mu3 is equal to phi 3 given mu1 is equal to 0 0, mu2 is equal to 2 3. Enter your answer correct to the 1 decimal places. So the first mean is mu1 is 0 0. So A is our first mean and the second mean 2 3. So D is our second mean. We have to find the probability that phi 3 F is our third mean. Now consider some basic concept. What is a k-means? A k-means is a clustering algorithm. Its purpose is to divide the data into two groups, that is clusters. Suppose we have students with a different marks. Group A has a marks 90, 91, 89, 88 and group B has marks like 20, 18, 25 and 22. K-means automatically separate them into these two distinct groups. What is a cluster mean? Each cluster has a representative point. That point is called as a mean or cluster center or centroid. The centroid is simply means the average of all the points in that cluster. Why isn't ordinary k-means enough? Suppose we randomly choose all our centroids very close together. Example, all 3 centroids lands exactly in the same region. Then they are bunch up. The algorithm will perform poorly. In many ideas, the main idea of the k-mean plus plus is that fix the centroid problem. K-mean plus plus fixes the problem of ordinary k-means. Instead of choosing centroid completely randomly, it uses a smarter method. It prefers points that are far away from the already selected centroids. The very first centroid is chosen randomly. After that, every new centroid is chosen based on a specific probability. Which points are already selected? In our equations, mu1 is equal to 0 0 and mu2 is equal to 2 3. So these 2 points are already selected as a centroid. Therefore, these 2 points are not candidates anymore. The remaining candidate points will participate in the probability calculations. So points remains are 2 0, 0 3, 5 0 and 5 3. And probability is calculated by the formula probability of the x is equal to d of x square divided by summation of d of xi square. Probability is proportional to d of x square, where d of x means the distance from the point x to the nearest already chosen centroid, and probability of the x represents the probability of selecting point x. How to calculate the distance? We will calculate the distance by using the Euclidean distance formula. D is equal to square root of x2 minus x1 square plus y2 minus y1 square. Now calculate the distance for first two candidate. The candidate is 2, 0. Calculated distance from our first mu, that is 0, 0. So by substituting the values in our Euclidean distance formula, we will get its distance of point 2, 0 from the first mu is 2, and distance of point 2, 0 from our second mu 2, 3 as a 3. The nearest distance is 2, and then square it, because we need, for probability formula we need square distance, therefore it is a 4. Similarly, compute the distance of our second candidate 0, 3 from our first mu 0, 0, it becomes 3, and distance of point 0, 3 from our second mu 2, 3 is 2. The nearest distance is 2. Square it, it becomes 4. Similarly, calculate the distance for other 2 points, that is 5, 0 and 5, 3. For the candidate 5, 0, the nearest distance is square root of 18. The distance, that means 18. For candidate 4, 5, 3, the nearest distance is 3. Square it distance, so it becomes 9. Now prepare a final table where all the square distances together to find the summation. So 4 plus 4 is 8, 8 plus 18 is 26, and 26 plus 9 is 35. So summation of all distances is equal to 35. Now compute the probability. Substitute the value d of x square divided by summation of d of x square. D of x square means distance of 0.53. So it is a 9 divided by 35. So 9 divided by 35 is 0.2571. So our answer is 0.26. Thank you.